Hello everyone, welcome to another mathematics and GIS lecture video. And in this lecture video, what I want to do is I want to begin our introduction to the underpinnings of trigonometry as they relate to the idea of map projections. And what I want to do is I want to talk about the most basic map projection first. And that would be basically converting from x and y based on the idea of the polar coordinates that we talked about before. Right, so this diagram is going to be one that we're going to be using over multiple videos. So I would highly recommend that you pause the video now and write it down in your notes. And so what we've got is my best attempt at drawing a sphere. Right, so this line right here, this is the equator. Right, and this line right here, this is our central meridian, which we would typically call the prime meridian, or the meridian that runs through Greenwich, England. And then these red lines are the straight lines cutting through the center of the Earth, connecting east and west and north and south. Where they intersect, right, this point we called O, this is the center of our sphere. This would be the origin. And then we have this point here, P. Now the reason I labeled P is because P is the center of the Earth shifted up to match the latitude of B and C. So the latitude of B and C, if you were to draw a straight line back, this was a different color. If you were to draw a straight line back from B and from C, you'd hit P. So what we've got here, we have several things that we need to consider. The first is the angle between E, which is where the line that cuts through the center of the Earth hits the Earth's surface at the horizontal. We have the point N, which is the line where that cuts through the center of the Earth's surface, hits the Earth's surface in the north direction, so this would be the North Pole. Then we have the points B, with some angle, and the point A with some angle. Right, so this is the sort of latitude, right? This is our latitude. This is our latitude. So we're going to call this angle here, we're going to call this theta A. We're going to call this angle right here theta B. Right, and we're going to call the difference delta theta. Right, we're going to call this angle, we're going to call this angle right here, the difference between A and B, we're going to call this delta theta. So the delta sign, delta theta. Okay. And so you can imagine, right, we have an arc that connects A to B. Okay, so that's this setup here. And you can imagine we have the same setup for C, right, because B and C are on the same latitude. So you can replace B and C and you'd end up with the same thing. Let's talk about going east and west. So talking about, in this case, longitude. So we have O, we have E, so then going out, right, we have some angle, some angle A. Since this is longitude, we're going to call this lambda A. And then we have some angle, in this case I'm going to use C, And we have some c floating out here, and we have some angle. We're going to call that lambda c. Right, and again, just like before, right, this difference right here, the difference between A and C, we're going to call this delta lambda. Okay. And so one other thing I want to draw your attention to is this point, P. And what I want to do here is I want to actually draw out what we're talking about here. So we're going to call this point, again, this is going to be point P right here. We can extend it in this direction right here. This is going to be point C. We can extend it in this direction here. Right, and this is going to be point B. And so you can imagine this is going to be some arc, which we will call CB or BC. Right? So this is going to be PC, and this is going to be PB. And this angle right here, right, the difference between B and C, right, this is going to be the same difference, right, as our latitude was, as our longitude between C and A. Because again, B and C and C and B are the same thing. So this is going to be, again, our delta lambda. Delta lambda. So we have delta theta equal to the difference in latitude between A and B or A and C. We have the difference between longitude between C and A as delta lambda. And then we have, in specific, talking about C and B, we have this delta lambda showing up again, and then we have these lengths. Okay, so this is sort of the setup going into talking about the different ways that we can handle projections. So hopefully this makes sense. If you have any questions, please reach out. Thank you.